this lesson we're going to have a look at inverse proportion. We'll start with a real-world example and then build the algebra step by step. Finally, we'll solve some exam-style questions. By the end, you'll know exactly how to recognise inverse proportion questions and how to deal with them confidently. Let's think about a real situation. A car is travelling a fixed distance of 120 kilometres. How long will it take the car to travel 120 kilometres if we travel at 30 kilometres an hour, 60 kilometres an hour, or 120 kilometres an hour? Well, since we know that speed equals distance over time, we can rearrange to get that time equals distance over speed. So 120 divided by 30 is 4 hours. 120 divided by 60 is 2 hours. 120 divided by 120 is just 1 hour. Notice something important here. When the speed doubles, the time halves. When the speed halves, the time doubles. As speed increases, time decreases. This is inverse proportion. We would therefore say that time is inversely proportional to the speed. This means that time is proportional to 1 divided by the speed. We can cast our mind back to the last lesson we did on direct proportion, and we know we can swap the proportional to sign for equals k times. So t equals k over s. So we know that speed was 60 when time was 2 hours. We can substitute this in and we get that k equals 120. So the equation becomes time equals to 120 divided by the speed. Notice that 120 is the fixed distance. So in inverse proportion we say that the product of the two variables will stay constant. Let's do a real GCSE example. Y is inversely proportional to x. When x equals 4, y equals 6. Find y when x equals 3. The first step here is to write down the relationship. Y is inversely proportional to x, so y is proportional to 1 over x. We can swap this for y equals k divided by x. Our second step here is to sub in the known values, so y equals 6 and x equals 4. By multiplying both sides by 4 we get that k equals 24. Step 3 would be to write down the full equation, so y equals 24 over x. Our fourth and final step would be to sub in the new value of x equals 3. So y equals 24 over 3, y equals 8. Graphically, inverse proportion does not produce a straight line like it did for direct proportion. Instead, we get a curved graph that gets closer and closer to the axes. As x increases, y decreases, but it never actually reaches 0. You'll be expected to know what different graphs look like in your exams, so it's definitely worth learning. Let's do another exam-style question, but using that same 4-step approach. Y is inversely proportional to x. When x equals 5, y equals 12. Find y when x equals 8. So step 1, we're going to write down the relationship. So y equals k divided by x. So step 2, we're going to sub in the known values. So 12 and 5. 12 times 5 equals 60, so k equals 60. Step 3, we can write down the full equation. So y equals 60 over x. And finally, step 4, we're going to sub in the new value. So 8. Y equals 60 divided by 8. Y equals 7.5. It's the same structure every time. Now let's try something more challenging. This time x is inversely proportional to the square of y. When y equals 2, x equals 10. We've been asked to find x when y equals 5. We're going to follow the same 4-step approach. So step 1, we're going to write down the relationship. So x is directly proportional to 1 over the square of y, or x equals k divided by y squared. Step 2, we're going to sub in the known values. So 10 and 2. 10 equals k over 2 squared, so 10 equals k over 4, so k equals 40. For step 3, we're going to write down the full equation, so x equals 40 over y squared. And finally for step 4, we're going to sub in the new value, which is y equals 5. X equals 40 over 5 squared, which is x equals 40 over 25, so x equals 1.6. So here is our 4-step approach. I'd recommend learning it because it's going to be really useful for your exams. Whether it's simple inverse proportion or inverse proportional to the square or cube, the method is identical. Write down the structure carefully first. This is where most of the marks are going to be earned.